So we look at thermal expansion. So what do you understand by thermal expansion? Have you heard of this term earlier? Okay.
The expansion takes place when heat is supplied.
Yes, exactly. So the substances expand under heating. Whenever we heat substances, no, they will expand. That expansion is called thermal expansion. So if you see the definition, simply expansion of substance under heating. That is called thermal expansion. Now the question is, why do they expand? Okay, whenever we supply heat energy, why do they expand? That's not there as a part of your syllabus, but we'll try to understand and make little bit sense of it, why it happens. Okay? So, do the solids expand? Do the liquids, gases? All matter will expand. Okay. The reason why they expand is, we will take one substance, let's say that is a solid. So we know that all the matter consists of particles. Okay. These particles, when we supply heat to them, okay, that is what heating is, right? So we supply heat energy. When we supply heat energy, what happens to those particles?
They start moving vigorously and so they move away from each other.
Perfect. So they will move with the vigorously, correct? They will vibrate vigorously. So initially the distance between these two particles is this, correct? When I supply heat energy, it will start moving this way. That will also start moving that way. Okay? Slowly the distance between them is increasing, isn't it? So the heat energy supplied will cause them move vigorously and then they will expand. The same is true with the liquids and also the gases. Okay? Now, once we understand that there are three types of expansions, thermal expansions, there are three types. So I will list all those three and then we will look into one after the other. So three types of expansions. What are those three types? One is linear thermal expansion. One is called linear. The second one is called superficial. Okay, superficial. Third one is called volume thermal expansion. Linear thermal expansion, I am writing in short TE. Superficial thermal expansion, volume thermal expansion. So those are the three types of expansions that we have. Okay. For example, let's take you have a rod. You have a uniform rod. When I heat this uniform rod, okay, when I heat this, what would happen to it?
It starts
Expanding, and then its length will increase. Correct? Length will increase. So, whenever there is a change in length or increase in length, that is called linear expansion. Because only one dimension, that line is increasing. So, the length is increasing. So, whenever the length increases, that is called a linear thermal expansion. For example, if the object is in the shape of a plate, okay, when I supply the heat, which dimensions will change? This has length, this also has breadth, correct? Both length and breadth will change. That means initially this is the rectangle. So after heating, let's say it increased by that much. And then that means its area has increased, isn't it? Not just one dimension, two dimensions have increased. So that means superficial thermal expansion means if the area increases, okay, here only the length is increasing, okay, here the area is increasing. So then it is called superficial thermal expansion. What is volume thermal expansion? Volume thermal expansion means the volume is increasing now. So let's say we have 3 dimensions now. Instead of 1 dimension and 2 dimensions, let's say we have 3 dimensions. So let's take, for example, you can take a cube. Okay, cube. You take a cube. And then if you heat the cube, its length will increase, its breadth will increase, its height also will increase. All 3 will increase. That means its volume increases. So linear thermal expansion means increase in length. Superficial thermal expansion means increase in area due to heat. Okay, volume expansion means increase in the volume. So these are the 3 definitions. That's all. So take down these 3 definitions. Now, we will compare the magnitude of expansion between gases, liquids and solids. When you supply same amount of heat, let's say we are supplying 100 joules of heat to same mass of gas, same mass of liquid, same mass of solid. When we do that, gases will expand the most, and then liquids, and then solids. So this is the order in which they will expand. So the gases will expand the most, liquids next, and then solids very little. Because we usually don't see solids expanding, isn't it? Because their expansion is very little, so that is not much perceptible. Liquids, okay, we can understand. When we heat it, they will boil and they will rise. Okay, gases even more. Okay, even a balloon which is filled with a gas, when it is actually heated or when the temperature outside is more, it will increase in dimension. And also it will deflate during the night. Because it will deflate just because the temperature is down and it will cool down and the volume will reduce. So it's easily seen in terms of gases, then liquids and then solids. So this is the order of expansion. Just note that